Okay, so we're going to spend the entire unit talking about how we can analyze different functions, their behavior, and things like that. Lots of different features. So today we're going to talk about describing function behavior on intervals. And this part is really important that we're always talking about intervals. We're going to get really familiar with interval notation. This is one we should be familiar with, this parent graph, top half of a sideways parabola. If you make it look like this and label these 3 points, I'd be thrilled. Oh, I'm frozen, aren't I? Thank you very much. Okay. 0, 0, 1, 1, and then 4, 2. That'd be good enough. Okay. And that should take maybe 10 or 15 seconds. Should go really quickly. Okay. So again, just a reminder about how interval notation works. Interval notation describes a range of numbers. We normally go from the smallest number in that range to the biggest number in that range. So they would look like things like this. So this is the range or the interval from -2 to 19.3, including 19.3. The interval from 4 to infinity, including 4. 5 to 20, including both endpoints. And then always when we do infinity, negative infinity to infinity, it's always going to have round brackets. So the square means it's included. The round means that it's not. And then I'm hoping that some of these sound familiar. So a couple of things to keep in mind. Would you put a star by this? The reason we use intervals to describe what's happening with a function is it tells us where to look on the x-axis as a reference. And here are some of the things that we're going to be looking for. Mason, will you pull the door shut? Okay. A function is increasing on an interval when the function values are rising or going up from left to right. So as we look at that function from going from the left side of the x-axis to the right side of the x-axis, are the function values going up? Is the graph going up? Or are they going down? A function is decreasing on an interval. And again, notice that this always happens on an interval. If the values are falling or they're going down from left to right. So if we look at a picture of the graph and the graph is going down from left to right, we call that decreasing. And if it's not increasing or decreasing, if it's just staying the same all the time, anybody know what we call it? Yes.
Increasing.
Very nice. Okay, we call it constant. Okay, we call it constant. It has the same y value. The y value is a constant. The function value stays constant, so it just stays the same. So we call that a constant function. Then a function is positive. This might seem weird that we have to say this. A function is positive when f of x is greater than 0. In other words, when we look at a graph, it means it's above the x-axis. If the graph is above the x-axis, then the y values are positive. Okay? If it's below the x-axis, so we can fill in this one right here, if it's below the x-axis, then that would mean the function values are negative. What does that mean if it's right on the x-axis? What are the function values? What are they? Right idea. I'm looking for an actual number. What if the function is right on the x-axis? What is the function value on the x-axis? It's not positive and it's not negative. It's 0, which if you remember when we were doing the calculate, if you want to find x-intercepts, what was the thing that we used on the calculator? We hit calc and 0 because we want to know when the function value is 0. Okay? So despite the fact that we have to look at y values to determine whether or not it's increasing, decreasing, positive, or constant, all that sort of stuff, we describe where things are happening by using x coordinates. So here's what I want you to note about this. And this is true now. It's going to be true when you're taking pre-calculus or calculus or anything like that in the future. It says find intervals where the function, here's the function, is doing this stuff. So here's a graph of this. So they did us a huge favor. So it looks like the vertex is right there at -1, -4. So I'm just going to mark that. -1, -4. That's kind of a critical point because it's the minimum function value. So here's what we want to describe. Where is the function increasing? Okay, now a lot of people will say this. I need you looking up here because this is the most common type of mistake. They'll say it's increasing here. So it's increasing when it's going from -4 all the way to positive infinity. we're saying where it's doing this according to the x-axis, so it's increasing on this part of the x-axis. It's increasing from -1 to infinity. That's the interval on which it's increasing. So the answer to where it's increasing is -1 to infinity. We're going to do a round bracket on both of them for the time being. We're going to do a round bracket on both of them for the time being. Where is it decreasing? Well, it's decreasing over here, not from infinity down to -4, but it's decreasing on this interval. Where do we look on the x-axis to find where it's decreasing? Well, it's decreasing from -infinity all the way to where we get to -1. So, where is it decreasing? -infinity to -1, and we're going to use round around each one of those. Now, is there anywhere where it's constant? Got some hands up. Are there any intervals on which it's constant? The answer to that is none. We can say none or we can say NA, because if you'll notice on each one of these, increasing, decreasing, constant, those are defined on intervals, not at specific points. So if you wanted to, we could have put a square bracket around each one of those. We could have counted -1 as a place where it's both increasing and decreasing if you wanted to. It's usually better to do this. Okay? Now, where is it positive? Where is it above the x-axis? Luke?
From -infinity to -3.
Uh-huh.
And from 1 to infinity.
Very good. Okay, now you may remember things like this. We've got two pieces where it's positive. It's positive over here and it's positive over here. Those are the places where it's above the x-axis. So we have two separate intervals, and the way we put those together is we use that union symbol over here and over here. Happens in both places. And then where is it negative? Well, that would be the other stuff. That would be from -3. Whoops. That would be from -3 to +1, and we do round brackets there. Okay. Any questions? I'll give you a second. A lot of analysis going on here. Okay, let's take a look at the next one. Different function. This is a cube root. They were nice enough to graph this for us. This is a very nice picture of it. So we want to know the intervals on which it is increasing. Where is the graph going up? Where is the question about the x coordinates? Anybody want to raise their hand and tell us what the answer is? Wilson's got his hand up. Wilson, what do you think?
-infinity to infinity.
-infinity to infinity. It's always increasing. Well, if it's always increasing, it's not going to be decreasing anywhere. It's not going to be constant anywhere. Positive? Lydia, where does this start being positive? At -1, and then it continues being positive on the rest of this. So this is going to be from -1 to infinity, round around both of them, and then Caleb, where's it negative? Very good, round around both of those. And what I like is the fact that when these guys answered that, they were saying from smallest to greatest, nobody was making that mistake. Please make sure you keep track of that. Okay, again, at the bottom of the page, it's worth pointing out that increasing, decreasing, and constant, those only happen on intervals, not at specific points. So we wouldn't look at that point at the vertex and say, oh, it's constant there, okay? You'll deal with something like that when you get to calculus, but we're talking, these are only defined on intervals, okay? So flip the page over. Mason?
Would there be a way to do this entirely algebraically?
Yeah. We'll talk later. Much quicker if we graph it though. Okay, we should know what this shape is. We should be able to draw it pretty quickly. This is the top half of a sideways parabola. It's twice as tall or twice as steep as it used to be, and it got moved to the right. Looks like that, right? Do we need any more specifics other than that? Increasing on 3 to infinity. Lizzie, is it ever decreasing? Nope. Hannah, is it ever constant? Nope. Positive, Si.
3 to infinity.
3 to infinity. And if it's positive everywhere on its entire domain, then it's not going to be negative. Okay. So we could say none right there. Easy enough? Goes pretty quick, right? We're looking at these specific behaviors on intervals. Where can we describe where this stuff is happening using the x values? Okay, take a look at the next one. Abby, if they've got absolute value in them, they're always roughly what shape? A V shape. They've got a V shape in them. Okay. Megan, what does that 4 do? Right 4. Okay. Lydia, what does that +1 do? 1, 2, 3, 4. Up 1. So it looks roughly like this, right? Dane, increasing.
From negative 30. Wait, no, I'm stupid. 4 to infinity.
4 to infinity. Okay. And we disagree with your first statement. Andy, where's it decreasing?
From negative infinity to 4.
Negative infinity to 4. Again, I like the way you guys are putting them in the right order. Excellent. Crew, is this ever constant? Not on an interval. We could maybe make an argument that, hey, right there at that point, it's really not doing anything, but not on an interval, it's not constant. And then positive. What do you think, Caleb?
It's positive from negative infinity.
Ooh, that's interesting. Jack, do you agree it's positive from negative infinity to infinity?
No.
Jack does not agree. D,
No,
we're gonna.
yes.
You change your mind? So we have no disagreement between you and Caleb? We don't need to duke it out or anything? Okay, they're right. Negative infinity to infinity. On the entire domain, it's always positive. It's always above the x-axis. We can tell that again really quickly by looking at it. It's never above the x or never below the x-axis, so that means it's never negative. Jack.
If it didn't have the +1, does that mean it would have like the 0 be positive?
Excellent question. I love the what if. Here's Jack's question. What if it didn't have the +1? If it didn't have the +1, it would do this. That would kind of mess things up just a little bit because would it always be positive? Nope. The easiest way to take care of that, don't write this down, would just be to say except for where x equals 4. Okay. Is it negative? The black one that I've got right there? The answer on that would still be none. Okay. It would mess up where it's positive, but it wouldn't mess up where it's negative. Does that answer your question? Love the question. That's great. Take a look at this next one. And then we're going to talk about something called end behavior, which is something that you looked at last year. So I'm hoping it's just a reminder. Piecewise function. Now, if I haven't called on you yet, I'm probably going to call on you for some of this. So we got a picture right here. That's nice. Increasing, need an interval. Decreasing, need an interval. Constant. We haven't run into any so far, but we'd need an interval if that was the case. And then positive and negative, we'd need an interval. D, you didn't get to weigh in on that last one at all, so we'll let you have a crack at increasing. Where's it increasing?
Is it from -1 to infinity to negative infinity to -1?
Negative infinity. So negative infinity to -1 would be along here. Is that where it's increasing? Where's it increasing?
It's from 2, 2 to infinity.
From 2 to infinity along here. Okay? Anybody want to politely disagree with that? Keely?
Wait, would it be 1?
It would be. Isn't it increasing all the way along here? It's going up from left to right. When we describe where that's happening, we just need to tell people, hey, here's where you look on the x-axis to find that type of behavior. If you look from 1 all the way to infinity on the x-axis, you'll find that the function is increasing along that entire thing. Are we good with that? Okay, Lizzie, can you help us out with the decreasing? Where is the graph going down from left to right?
From -infinity to -1.
Very good. From negative infinity to -1. We'd use round around both of those just to be on the safe side. Constant. Gavin, constant.
From -1 to 1.
-1 to 1. Now we're going to have a tiny little disagreement here, perhaps. Round or square?
-1 is square.
Anybody want to disagree with that? I don't have a huge problem either way. You can get away with either one because technically on this entire interval, from here to here, it is constant. You could also get away with a round bracket. That would be okay too. Either way is fine. Okay? Positive, that's going to be everywhere it's above. So we're going to have a whole bunch of stuff. We're going to have from negative infinity, check this out, all the way to 1, not including that. Why do I not have to worry about -1? Luke?
Because above the -1 there is another.
There is a function value. It's not 0, it's actually positive. So all of these values from negative infinity to 1, they're all positive. Then I have to start over when I get right here. I have to start over when I get to 2, and then I go all the way to infinity. We doing okay with that? That means the negative part of this graph must be the other stuff. It must be from 1 to 2 with round brackets around it, right? Mason.
I don't know why I raised my hand, but
Just for fun? Exercise. We'll call it exercise. Burning some calories. Okay. Last thing I want to get to this. I'm hoping that these are pretty easy because you should have seen this last year. This is called end behavior. And the cool part about this is where we actually start getting into some notation that you use in calculus a couple of years from now. So left end behavior is exactly what it sounds like. What does it look like out on the left? And when we say left end, we're talking about way down near negative infinity as x goes to negative infinity. Right end behavior is where it goes to positive infinity. What are the y values? What's happening to the function values? And there are 3 very common things that happen. It either goes to a particular number, it kind of settles off on one single number on either side, and that happens when we have an asymptote. Okay? The other thing that can happen is it can go toward negative infinity. So it would look something like this. On the left side, it continues going down, or on the right side, it continues going down. Oh, I need to fix this. Let's make that a plus, okay? So that it matches up. I got to catch that typo. Still catching those. That means it goes up on either end, on the left end or the right end, depending on which one you're trying to describe. And then if it goes to negative infinity, that means it's going down on either end, okay? So if we take a look at these examples down here, here we've got a sketch. We've already got a sketch on this one, and all we have to do is just, take that back. Now we have a sketch. This is negative 4x plus 3. This would be a line that looks like this. So as we're going to the left, the function values are continuing to get bigger and bigger and bigger. So that would be positive infinity. That would be its end behavior. As we're going to the right end, toward positive infinity, the function values continue going down. So that's negative infinity. Okay, now I left these off so that you'd have to write a couple of these. So for end behavior, we're going to say as x goes to negative infinity, and then we're going to have f of x equals. And we're going to think about what shape this is. Crew, what shape is this graph?
Parabola.
A parabola. Does it open up or down?
It opens down.
It opens down, so it looks like this. So what happens on both of the ends, whether you go to the right or the left? Heads toward negative infinity. So the end behavior on both of those is negative infinity. We can sketch this. Right 2, down 1. Going to look something like that. Does it really have left end behavior as we go to negative infinity? It's not even part of its domain. So we're going to put NA there. Right end behavior, we're going to fill that in. So as x goes to infinity, f of x approaches. What happens to this square root graph the further we go out to the right? It slowly gets bigger and bigger and bigger. So that's going to be positive infinity. Okay? Now, I'm going to hand out the assignment. While I'm handing out the assignment, would you look at D? What type of graph is D? It's got a name. We didn't pay attention in our class. I'm offended if you were in my class last year. What shape is it? Side. It's an exponential. Okay? So, on the left end, it approaches negative 2. This means it has an asymptote of y equals negative 2. An asymptote is a line that approximates the graph. It gets really close to y equals negative 2. And what happens on the right end? Goes to positive infinity. Now, I'm going to leave you with a thought question, and this is not too much. These go really quickly. I want you to do the whole assignment. Is that function increasing, decreasing, constant, or a mix of those? I want you to think about it. How many say increasing? Okay, we can ignore decreasing, right? How many say a mix? It's got some constant in there. Talk about it tomorrow. Have a great day.